Yes, hi, welcome everyone. I can actually not see you really, but I saw people before, so that's nice that everyone is here. I'm pretty amazed by all the stories that have been shared from Supermicro now and from WeWin and also from ByteDance on how they work with Open System Firmware, so it's great to see actually that this moves on. Okay, so I want to talk a little bit about speed up the development and ease maintenance through Open System Firmware, right? So what can you gain there? And also a little bit about how does an open development model works, what needs to be in place, what you should do and should not, and these kind of things. So it's like more of a meta kind of talk rather than super technical. Yeah, my name is Chris. I work for 9 Elements, and I'm managing the firmware department basically there. We are the biggest independent BIOS vendor, which is concentrating on open source, right? So, right. Okay, let's go through the agenda a little bit. So first off, I'd like to spend a couple of words on the importance of system firmware. So why do you care, and why do we care, and why should you care if you don't really? About the platform enabling process, how do we enable platforms? What does the traditional model looks like roughly, and how does that differentiate from the open model? Then I will dig a little bit into the open development model, explaining what you do there and what you don't do there and how this can be set up. I brought a couple of showcases where we went with an open development model and it worked pretty well, and finish everything up with call to action, basically. All right. So why do we care about system firmware, right? And it actually all boils down to that system firmware represent business, right? Obviously. It actually extended nowadays, like the value of system firmware extended from just booting to really represent your business, right? On the first hand side, you got the user experience, you need to take care of that. User means like internal users or customers, but also external users and customers. Like how do you want to customize your platform? How should it boot? Do you care about boot time or anything else? System firmware has an impact on security. So depending on what model you choose and how you can configure it, it can reduce the attack surface or not. So depending on the solution that you choose, there's more security-orientated solutions or not. It has an impact on your development process, obviously. So that means when you develop open system firmware or choose an open development model, your development model is just different from the traditional one. And I will go into that later as well. And that includes maintenance of the systems themselves and also time to market, for example. And it has an impact on your costs. And with costs, like the development model obviously is connected to the costs, right? So, but also, there's a nice talk from Subrata that he did on this year's OSFC, where he made the connection of choosing which firmware, like which open source in that case, which firmware you're using can optimize, for example, your bill of material costs, right? So because you got probably a smaller footprint and can probably choose other parts. So that also kind of plays a part into system firmware. Okay, how does the traditional platform enabling model looks like? The traditional model is highly controlled by the SoC vendors, basically. The SoC vendors and the traditional IBVs have like very good working relationship. So it's like a 1-to-1 or 1-to-5, or a couple of IBVs only out there. Relationship. SoC vendors and the traditional IBVs kind of share reference code and documentation with each other, like NDAs are in place, and so they work very closely together. And where that basically scales then is at the IBV, right? So the IBV then enables the platforms for the OEMs and ODMs, basically, and supports them while enabling these platforms. So it's like a 1-to-1-to-N connection, let's say. Switching to an open development model, that kind of changes a little bit. And that's probably my own opinion, but it's a more scalable approach here. So what changes now is that you don't have this 1 to 1 to N connection anymore, but you got a 1 to N and then to N connection. Because instead of having just the IBVs enabling the OEMs and ODMs, you got multiple enablement partners that enable the platforms together. I think you saw that throughout the last 3 presentations, basically, that there was collaboration between the partners like WeWin and ByteDance and Intel to enable their platforms, right? So instead of having that streamlined process where you just go SoC, IBV, and then enable the platforms, basically, you got more partners being enablement partners. And that includes OEMs and ODMs. That also includes the SoC vendors. That includes independent software vendors, independent BIOS vendors, and the community itself. And that means that these partners basically develop and so enable platforms together and develop features together as part of, or as a community, let's say. The crucial thing here is a little bit that it changes now. So the SoC vendors and the traditional IBVs still have a very good working relationship. And the SoC vendors basically need to provide the same amount of support also to the enablement partners now, which can be a little bit challenging at first. But once the enablement partners get up and running, they can most likely help themselves out a lot. You saw that also in the presentations that like WeWin and ByteDance help each other on debugging the problems. The open development model. So what changes basically, right? With a closed development model, most of the time what you do or what you tend to do is that you have like a fork and forget model. So at some point in time you fork the code, basically. You get the reference code, you get code from your IBV, whatsoever, and work on that part of the code. During development, so during active development, that gets still rebased and merged, so that still gets updated. But at some point in time, when you are at a stable version, or when you get your system up and running and do stable releases, you only get like minor features in, a couple of security patches, but the code itself doesn't evolve anymore, right? And that differs a little bit from the open development model. With the open development model, you should not do this fork and forget approach. I think Johnny just mentioned that in his talk, that for the OCP Delta Lake, we did an upstream first approach, meaning that everything that we developed on top of the master tip of coreboot in that case. So that means with the open development model, you should try to work upstream as close as possible. So that means only what cannot really be published in the first place. And that is looking at the current Sapphire Rapid code that we developed in a closed source or in a private repository. That's like 95% of the code does not have to be private, actually, because there are no NDA information in there. So that means work upstream as close as possible as you can. Try to push your patches, so the code upstream as fast as possible and as early as possible, and only keep like a minimal amount of that code basically private. We experience that now, that if you keep a lot of the code, the bigger chunk of the code in a private repository, and say you want to upstream it now after 6, 9, or 12, or 18 months, or whatever time frame, that's a lot of work. So we spent like the last weeks really rebasing everything on top to the coreboot master tip to make it running again, because if you develop it privately for 12 months, obviously the upstream repository moves on, right? And 12 months is a pretty long time, actually, without any updates. So that means this is a very tedious work to do, and you have to enable it to work again, basically. Second thing that you should care about is enable the community. That kind of plays together with that you upstream your code as early as possible, right? Coreboot, for example, builds all mainboards in the tree. So that means they at least do build verification for you. in that case, if the project moves on and new features get development, at least the project makes sure that the code builds still for your board. If you even enable the developers or the community itself to access your hardware in any case, and that could be, for example, through the OCP, OCP lab, community lab, I think I called that Open System Firmware lab, but it's the same thing. The community can test their changes on your hardware directly, right? So they do validation for you if they enable it. That's a pretty nice thing, and that can really, really save you some work there. Very crucial actually is that you enable communication between the partners. So that means if you look back in these enablement partners here, it's very crucial that they can talk freely to each other. As you can see, we are always hitting the same problems over and over again. And having a group of partners working on the same code base, basically, hitting the same problems really enables you to move much faster than going through some support or whatsoever. This is really one of the key things, actually, that speeds up development a lot here. Yeah, and as it says, like, most likely you're not the first one with the problem, so that means that it can really move faster there. All right, I brought a couple of showcases here where we used an open development model really to move forward. I think the most prominent one is the one from Jonathan and Reddy, basically, that you set up or initiated in the first place. That's a multi-party NDA group that enables Sapphire Rapids with Coreboot together. That was basically the last representation that you saw there. So it's a consortium of over 10 companies now, I guess, working together on enabling Intel Sapphire Rapids SP with Coreboot, basically. As you saw in Johnny's presentation, only 2.5% or between 2 and 3% of the code is actually mainboard code. So that means that we are working, like, large amount of the code is actually shared through all the platforms. That also means that if you're hitting any problem or whatsoever, that most likely all others hitting the same problems. And having such multi-party NDA group in place that we can discuss these problems is very, very valuable. Yeah, we got it running on multiple servers that you already saw. They are all running Coreboot and Open System Firmware at that time. The upstreaming is in progress. As I just said, we had to rebase it a lot because we chose to develop a lot of code in a private repository, so that that was a little bit tedious to like rebase everything now, but we did the job, and now we are slowly upstreaming all the changes here. And what we experienced is that if new companies come into the effort and start working on their platforms, they really get up and running in 2 weeks, right? So when first touching Coreboot there, because Coreboot is pretty similar to the Linux kernel, they really get this platform up and running within weeks, which is really great to see because, yeah, as I just said, like, the majority of the code is actually shared, so it's really easy to move forward there. We got CXL enabled also in Coreboot. I think that was an effort that Jonathan also drove there. And we actually enabled it faster through Open System Firmware than we did than in closed source UFI, which is a pretty good hint to see that if you work together and with partners, you can enable things and features faster here. And the last thing that I brought is the Intel CBNT. I talked about that extensively with Johnny last year. I had a small presentation on that, how we enabled Intel CBNT on OCP Delta Lake. But basically it boils down to that we got from 0 to production-ready code within 4 months, basically. And we wrote all the tooling ourselves to provision and test the platforms if everything is provisioned correctly. We found a couple of bugs in the ACM that we filed through IPS to Intel, which later got fixed. And the baseline, basically, to being able to do that was that we got that we had Intel supporting us with debugging the ACM, so that we got all the error codes and these kind of things to move forward there. But that was also pretty fast, and pretty good process there. Okay, so please get involved in Open System Firmware if you want to. So if you want to check it out, if you want to be part of the MPNDA group, you probably want to talk to Jonathan and Reddy here. Check out Coreboot, right? Even though I'm a Coreboot guy, there's also EDK2 that you can check out. We have a Slack channel where you can join in and where we can talk about Open System Firmware in general. And with that, I'd like to thank you. And I got the reference to the talk I was talking about earlier, the thing around system firmware, which talks about the BOM optimization and how these are connected with system firmware. Thank you very much.
There is some information is not correct. UEFI EDK2 is open source. Why you think it's not open source?
So what?
UEFI EDK2 is open source.
Yeah.
Yeah, but one of your side said that's closed source. See?
No, it's closed source UFI. That's a different thing. So EDK2 is an open source implementation of UFI.
Yeah.
Right? Yeah, but there's also closed source UFI.
Why you think closed source? UEFI is a closed source. UEFI is the interface standard. It's open standard. Everybody can download it.
Yeah, that's correct.
Yeah.
So it's
code is open source. So I think it's open source.
so it's more about the closed source implementation of UFI, to be correct. Yeah.
You can have closed source.
Yeah. No, the specification is open. Yeah. Yeah. No, that makes sense.